I'm just going to copy the player collision system into the monsters one. So in player, we'll just copy the world collisions stuff, and we'll just paste it right into monsters world collisions and just modify it. We'll just have to add a few things here that it's going to need, and spikes, and last grounded, because that's what we did with the other one. This won't be player, this will be monsters, screen position. And we'll also need the screen position for the monster animation to play it. So we can just go like this. Position is equal to screen position, which is equal to this. Get monster tile occupation, prevent illegal memory access, that's the same. And this part will be the same. And this is where we'll have some differences. So let's go and set monster properties. Well, we'll have to add a variable for bounding boxes, and then we'll add to the custom monster properties, or get monster properties, the bounding boxes for each type of monster. So we'll make these public too. Player knows what the bounding box information is. So bounding box, and let's also make an attack box. That's the region where if the monster attacks, that'll actually count so that it actually hits the character. So if you had a fighting game, you wouldn't want the entire character to count as hitting you. You'd want where they're actually attacking. In the attack animation, the attack's probably going to occur at a certain keyframe. You don't want the player to get attacked when they're trying to do their anticipation move, so that wouldn't make any sense. So we'll keep track of which key to trigger an attack at. So we'll call it attack key. That's the animation key where the attack is going to first have some kind of impact on the character. You could have an end attack key too, if there's some key where you no longer wanted it to have an effect on the character. Based on the way these animations are, though, we'll just need that initial attack key. Control F, get monster, should take us to get monster properties. Have to hit F3 again. And here we can set the bounding box. And I've already made calculations of approximately where this bounding box would be. So this isn't like a normal bounding box. It's technically the top left position from the center, and then the width and the height from there. So these are actually offsets from the center of the monster. The position that the monster is at is its root bone, which is in the center of the monster. And that's why you have this offset. This has to be negative 115. I'm going to add this rescale rec here. And what that does is it's going to rescale it so that it actually matches whatever rescaling value we're using. If we did a resolution dependent rescaling, that way if we do decide we want to use a different resolution, it shouldn't throw it off. So corner is that top left one times rescale. So now that'll be rescaled appropriately. Let's put return new rectangle int corner.x int corner.y, and we need the dimensions for it too. Vector 2 dimension, that's the width and height. Vector 2, and we'll say width height times rescale. That'll rescale both those values. And we just put int dimension x and int dimension y. Okay, let's go back down to here. So now that'll be properly rescaled. We'll set the attack box. Rescale rec, negative 130 and 30 to the right from the center for the monster. And we'll also need his feet, just like we did with the player. So let's add that too. We'll have to add an extra variable. Say bottom is ebox. You could say feet offset, but bottom's just a little shorter. Ebox.height. Plus about 11. And what this is the bottom relative to the center of the monster. We know the B-box Y is 115 up, and if we take the height, that will get us to the bottom of it, and then plus 11. That's how that works. Actually, should be minus 11. And we can correct this later too if we need to. The first key in the animation where the monster's attack will actually hurt you is key 1, because it's a very simple animation. So key 0 he's anticipating, key 1 he's actually in the process of attacking. We can give him a life value, say 3 hits and he's done. And this is kind of bugging me, so let's add that bottom variable. The only place we're really using it is in world collisions, so we'll just put it here. Float bottom. People usually frown upon putting variables here rather than at the top, because then they don't know they exist or where to find them. But these ones are only being used in here, but we need to keep track of them globally. So that's the only reason I'm doing it like that. For the Hellcat, we'll say a bounding box is rescale. And we will make a show collider routine, and that'll show where the collider is for the monster. And we'll do one for the player as well, and then that way we can see whether there's something we need to debug with where the collision boxes are. Like if we need to modify these values a bit. 380 bottom, move them up 11 pixels. Okay, and then attack key. And this one is tricky because he's got all those keys that are for the blade spinning, so it's actually key 11, whereas attack is actually going to end up hitting you. And we'll say he's a little more susceptible to getting hurt. We could also give him a damage value too, like maybe because this guy has chainsaws, he does more damage, and then this guy isn't quite as crazy, so he doesn't do quite as much damage, maybe a point less. There, that looks a bit better. Now, going back up to the moving up portion of World Collisions, we're going to change this player head offset. Our bounding box Y coordinate, it's a negative, so we'll have to add instead of subtract, because it's the actual offset rather than a positive distance. So this is like a negative value. And this 84 here, that's we can use the same tolerance. That's an extra 20 pixels, so it's 64 plus 20. So 20 pixel tolerance, and then he'll fall off. And you just got to remember that this position X is actually the center of the monster. Okay, and then for to the right and up, same theory, plus bbox.y. This thing's the same, won't change, it'll be minus 20 pixel tolerance. I just noticed we're seeing something strange here. This is copied from the player class. We've got up and to the left, and we've got up and to the right in moving up, but I don't see anything for moving straight up. Does that mean we can jump straight up into tiles? We should probably make sure we fix that. Let's go back to player. I don't think I tested jumping straight up to the tiles. Maybe I did, but I must have been close enough to the ones to the left and the right that it worked. If I jumped straight up and I was near the edge of the tiles, it probably wouldn't. I'm going to copy this from here, paste it here, and all we have to do is change this to X. And then that'll be y minus 1. And this should be the same, yeah. And oh yeah, this has to be different. Like right here, we don't care about the horizontal offset. So long as his head goes through the tile, that should be enough for a collision. And we'll save that. Let's copy this out. Oh, we gotta change this to up. And let's copy this out of here, paste it in the monster above these ones. So here it would just be plus bbox.y. Here, that should handle moving up. So not a whole lot to change to make these work. Okay, for moving right, half player width. Okay, we didn't actually record the offset to the right, so we'll just put it here. Half width is bounding box width divided by 2, and we'll just change this to half width. And like before, if the monster's on spikes and there's spikes to the right, and that's to the right where his feet are, then we're not going to do anything. We're just going to allow him to run over the spikes. And otherwise, any normal situation where we're hitting something solid to the right, we're going to prevent him from going to that position with this. So we'll just change this to half width. Let's go down to moving left, and I'll just paste that half width in these. And going to moving down, where it says player feet offset, we're using the variable bottom now. So copy bottom into each one of these. And moving down, it also detects whether he hit a spring or not, or walked over a spring. So if he does, it'll trigger the bounce manager to add a bounce event to that location and give him a bounce velocity. So we just have to trigger the monster jump. Play bounce will be true, and then we go down here and change this to monster jump 2. Yeah, we got another case here where we're going to need bottom, so we'll copy that, paste it in here. And going down to the x minus 1 plus 1, we'll paste bottom into these feet offsets again. And going down to plus 1 for both x and y, we'll do it again. And in x plus 1 and y, we'll do it there as well. And in here, we'll say if move.y is greater than 0, we'll say monster damaged 1. Well, no, we can leave it that way because he's got that invincibility value. Okay, and the rest of this should work exactly the same. If he wasn't on the ground last time and he is now, then it'll play a landing sound. And we said when we were working on Monster Sys that we also need to be able to draw him, so probably should add that right away. And we're only going to draw him if he's on the screen. So if his screen position.x is less than, that's the center of his body. The bounding box.x is a negative value, so we'll check to see if he's off the screen. So if his center of his body is halfway distance of the monster, then he'd be off the screen. So that's what that means if he's less than bbox.x. So he'd be like less than negative something. He's got to be off the screen. So find all the cases here where he's off the screen. So if screen position.x plus bbox.x, that's the position of the monster, the center of his body, minus bbox.x, so that's the left side of his body, is greater than the screen width. So the left side of his body is off the right hand side of the screen. That would also make him off screen. So let's check the y position. If that's less than bbox.y, so the center of his body is less than that negative distance to the top of him, then that's considered off screen. You might even want to increase these values a bit just to make sure they're off screen. So like instead of bbox.y, you might say, minus 50, an extra 50 or something. So if the y position plus that offset, which is the top of him, bbox.y, is greater than the bottom of the screen, screen h, then we'll just return. Don't need to do any more here. The only thing is we don't have access to screen.h unless we say game1 dot. I don't really want to do that, so let's just go back to the top here, and we'll put in screen width and screen height here, because we might reuse them in a few other places depending. And we'll go down, and right where we have this rescale here, let's add screen W is also the game1 screen width. See, in this way we never have to say game1 dot over and over again, because we might use it a few times in here depending on what we're doing. Screen height, I'll just put all these in one line. It occurs to me that we haven't actually called the update for the animation yet. So let's go to update. And in here, we'll want to make sure that we don't waste time calculating things that we're not going to see. So let's just copy that idea from down here. So we'll copy this out of draw. We'll go back up to the animation section, just after the animate section. Well, I guess it's part of the animate section in update. And we'll paste that in here. The only thing is we'll want to do the opposite comparison here. To do the exact opposite, we'd have to change these signs and change these to ands. So and the reason is we want to see if it is a situation in which we want to animate it. So if he is on screen rather than is off screen, that's why we've got to invert all this. This is greater than, this would be less than. So if all these situations are true, then we can go ahead and animate them. meow.player.update, and it wants game time. Okay, that way it's only animating that particular monster if he's visible. No wasted calculations. Also, if he gets hurt, invincible, meaning that he did just get hurt. Probably the player attacked him. He might have just hit some spikes and got scared. Well, we already have the logic for running away, so we'll just set else here for now. Invincible. We can count down the invincibility time until it hits 0, and then he's no longer invincible. And we'll make sure that the mode is set to run away. Actually, I guess what we could do here in invincible is say if he's in runaway mode, meaning he was just invincible a second ago, then we're going to set him to be in patrol mode first. As soon as he's done with his being invincible, he's going to go to patrol mode. He may decide to start wandering after a few minutes or after a few seconds. So this world collisions section is huge, so I'm going to make it a region. Actually, I'm going to do it like this. Region. Then I can just close this and I don't have to scroll past it. There. Okay, back in our draw area, we'll draw him at a color of white normally. It could be invincible. So if invincible, let's make it obvious that he's invincible. We'll do just like we did in the player class. Say n equals invincible, modulo 10, if n is greater than 5. So they'll do 5 in a row and then 5 not. Color 255, 155, 155. So the red value is 100%, and then we reduce the green and blue channels so that he'll be kind of a reddish tint. And because he's not a regular sprite, they're composed of layers. We don't really want to reduce the alpha channel, because if we do that, you'll be able to see layers superimposed on each other as he's flashing. But for regular sprites, you could do that. Invincible. We'll get into animating regular sprites when we do explosions. We just call them meow player draw with that color tinting. So the alpha animations will still work fine in here, regardless of what tint you use. That's it for drawing the monster. We may need to tweak his collision boxes though. So let's make a draw collider. Public draw collider. It will take sprite batch, texture 2D, text a rectangle, and that'll be S-box. Okay, let's resolve this. Actually, it's going to do a screen bounding box for the player, but if it's going to do colliders for every monster, that would be a bit redundant. Well, I suppose it doesn't really matter since this is only for testing, but we could actually put that in the draw collider inside Monsters5, where it's going to run through all the monsters and draw all their colliders. Let's go into Monsters5 first, and after draw for the monsters, let's add draw colliders. Colliders plural, taking in sprite batch and a texture 2D, which we'll pass along. And let's get the screen box for the player. We'll use converter bounding box world to screen. Player dot, whoa, should be equals player dot bounding box. We're going to assume that begin has been called. We'll say rectangle pixel equals new rectangle. And this will depend on your texture source. Wherever you have a white pixel on your texture map for your tiles or whatever you're passing in here, you'll want to use a source rectangle that's 1 by 1, somewhere where there's a white pixel. That can be stretched out to draw lines. So that's what we need that for. First, we'll show the player's vulnerable box. That would be sprite batch, draw lines. We'll have to add an extension. So that'll take in the texture, pixel, that S-box, and we'll use color.white for the player. We'll have to add this draw rect lines though. Go over to your Solution Explorer, right click on it, Platformer, Add Class. We'll call it Extensions. And this will be a static class. We can do this anywhere. Public static void, and we'll have draw lines. So now Sprite Batch will be able to draw lines. So this Sprite Batch, and let's resolve that. Takes a texture 2D text tangle called pixel to resolve again. The begin coordinate and the end coordinate for the line, and then color, and optionally a thickness. It'll default as 1. Say vector 2 delta. It's going to be difference between the two endpoints, and that'll just get the vector at an origin. So that's as though the beginning point is at 0, 0. Then we'll get a rotation value for that. We can use math.atan, arctangent, delta.y, delta.x. And if you remember your geotrig, I think the rule was SOHCAH TOA. TOA would be TOA, opposite over adjacent. So the opposite here is y, adjacent is x. We're doing the reverse to get the angle. Rather than saying tangent angle equals opposite over adjacent, we're saying arctangent, opposite over adjacent, what angle is that? And in this case, that vertical distance straight up and down is opposite, horizontal distance x is adjacent. We can say if pixel.width is greater than 0, pixel.width is 1, pixel.height is 1. There is a good reason for that. We're expecting to stretch out a 1 by 1 pixel. If the pixel's 2, like a width of 2, and you were to stretch it out, it's going to multiply that number by the scale that you want to stretch it out by. So if it was 2, it'd be twice as long. The line would be twice as long as it's supposed to be. So you can't use a 2 by 2 source or a 4 by 4 source or something like that. You have to make sure it's a 1 by 1 pixel source. By doing this, if somebody forgot and put it in wrong, that'll protect it from messing up. So sprite batch, draw, texture, begin, starting at the beginning position, that pixel source, color, and rotation that we derived from that vector. And for origin, we'll say 0, 0.5f, because I think that seemed to center the line better. And we'll say new vector 2, and this is scaling it, so we want to scale it to the right. At a rotation of 0, this would scale it to the right, and it does the scaling first. Scale it to the right by that length, and then it'll rotate it based on the rotation angle. And we can say sprite effects dot none, layer depth is 0, and you could have it so that this would actually put in a layer depth if you wanted. We'll just leave it like this for now. Sprite effects dot none. There, that's better. Now we want to be able to draw all the rect lines at once, so we'll say public static void draw rect lines. This sprite batch, texture 2D again, pixel source, rectangle, say R. That's the rectangle we want to draw, and the default thickness, we'll say 1. I'm going to use a slightly more efficient way of drawing this. Rather than using draw line here, I'll show you what I'll do. This will be a little quicker. Sprite batch draw. Same idea with the scaling it in a direction. That's all it is. So we'll go rectangle, rectangle.x. This is the coordinate for the top left-hand corner, going based on the width. So we're making a line going straight to the right. So the height of it will be thickness. It's our first rectangle. So because it's one thick, it's just a line. We'll use the pixel as a source and the color. So this will be our destination rectangle. Rather than scaling it, we're using the destination. Oh yeah, pixel should be a rectangle source, so this needs to be rectangle here. We can copy this line a few times and then just modify it. So this time we're going to go with r plus r dot width, so that coordinates over to the right side of the rectangle, the top, and we're going down, so its width is actually going to be the thickness, and its height is actually going to be r dot height. That'll make a line straight down. So we did a line straight across the top and a line straight down on the right side. And we can go with the point on the left,